Hi guys, today we're going to be looking at equations, and you guys have seen a bunch of equations, before, and just pretty much solved them by guessing and checking and seeing if you know what the answer is. So things like x minus 6 equals 10. Basically it says what number, when you take away 6, gives you 10. And you're probably thinking in your head, oh, that's 16. Today we are going to solve equations by showing you specific rules. And then we're going to follow those rules. Eventually we're going to get to solving equations like this. Something like that. Some pretty long equation. What we'll do is distribute, then we'll go through and combine like terms and isolate the variable. So we're going to actually look at that, isolating the oops, I didn't spell that right. Isolate the variable. And you'll hear me talk about that a lot throughout the next few weeks. And so, but the first thing we want to look at today is the difference between an expression and an equation. And this is very important. There's only really one difference between them. And it's one of those things that if people say the wrong word, it might not be that big of a deal, but to math teachers it definitely makes a pretty big deal about which one we're talking about. So an expression combines numbers, variables, and operations. It's kind of the building blocks of how we make equations. So every equation has some sort of an expression in it. So it combines numbers, variables, and operations. And an example of an expression would be 3 times x minus 4. There's multiplication, subtraction, numbers, and variables. An equation is something that has an equal sign. Basically, it's a mathematical sentence that has an equal sign. Let me say that combines expressions with an equal sign. Okay, so basically an expression, something like 2x minus 4 equals 10, or it could even be something like 10x plus 12, I don't know, something like that. So equations have equal signs, expressions do not. That's the big important idea here. Or I guess I should say they do not have equal signs like that. Alright, so we're also going to go on to what is a solution of an equation. When you say find the solution of the equation, it means it's the number that produces a true statement. When the number is substituted in for the variable. And that word substituted, it's kind of like if I have a substitute teacher, it means they're taking the place of it, or you'll hear me say a lot, plug in the number. Okay. So what we want to do first before we getting into solving equations is tell whether the variable is a solution or not. So our first question is 9 a solution to the equation x minus 5 equals 2? What we're going to do is replace this 9 with the x there. So instead of x, we're going to write 9 minus 5 equals 2. Pretty simple, right? Let's see if 9 minus 5 is equal to 2. Well, we know that 9 minus 5 is 4, and 4 is not equal to 2, so it's not a solution. Pretty simple and straightforward there. I bet you can probably figure out what the answer is there. A number, take away 5 gives you 2. That number should be 7. The next one here, we're going to plug 7 in for the x. So we can't just make this 37. It's not like we just get rid of the x and put a 7 there. Whenever we have a number next to a variable, like this, there's really a hidden multiplication symbol there. It's kind of math shortcut or math notation for that. So it's really 3 times 7 plus 5. 3 times 7 is 21. And we're not sure yet. When we do 21 plus 5, we do get 26. So we'll say that this one is a solution, or the number 7 is a solution. Try that next one on your own there. Okay, when we plug in -4, we're going to do 3 times -4, take away 2, see if it's equal to 14. 3 times -4 is -12. When we do -12 minus 2, we get -14. And even though they're the same number, definitely we know that -14 is not the same as 14. We'd rather have positive $14 instead of -14. So those are two different quantities. So here we'll say this one is not a solution. Sound good so far? Now we're going to get into how we actually solve equations. And those are called inverse operations, or kind of thinking about opposites. Opposite operations. So inverse operations, and this is just kind of a little definition. Actually, the best way here, let me cross this out here. Sorry, guys. I was trying to think of a good sentence, but it didn't make a good English sentence. Basically, inverse operations are two operations that undo each other. Okay, so, obviously, like, things that are opposites of each other, like getting dressed and getting undressed, or anything that kind of undoes what the operation was. So the inverse operation of adding 2 would be subtracting 2. Add 2, take away 2, you're back at the same spot. Okay? Or if you multiply by 3, the operation that undoes that would be dividing by 3. So those are the inverse operations that we're going to look at today. So we have two different properties that we're going to use today, and this isn't too big of a deal really, but we'll kind of talk about them just to see what they're called. The subtraction property of equality, that's kind of a fancy mathematical definition. It just says subtracting the same number from both sides of an equation produces an equivalent equation. And that's the reason why we can do what we're going to do today. It's like if you have x plus 2 equals 10, you can change this a little bit into, if I kind of give myself some more space here, you can say right away and change this and say x plus 2 minus 2 is equal to 10 minus 2. So we added this thing into both sides. And that's kind of how we're going to solve this today. 2 minus 2 cancels out. That's gone. And 10 minus 2 is 8. So that's what we're doing today. Likewise, we have the addition property, and that just says that adding the same number to both sides produces an equivalent equation. So the inverse of addition is subtraction, and the inverse of subtraction is addition. Okay, and the goal today, what we're trying to do, and I want you to write this down because we're going to reference it quite a bit. The goal is to isolate the variable. That's what we're doing. We're trying to get the variable alone. Everything that's around that variable, we want to get rid of it by doing an inverse operation. So we have a few equations we're going to look at, just really 6 to get us started today. And a lot of these you might be able to solve kind of in your head, and some of them you might not be able to. But we do want to be able to show all the steps. A lot of times students say, do we have to show our work? Do we have to do it this way? A lot of these you'll be able to do. But there's going to be a lot of equations like that one that I just showed you. When it gets complicated kind of like this, we definitely need to be able to show steps, because this is not one that you'll be able to see right away what's the answer. So that's what we're getting to. So what we're going to do, and this isn't a way that you eventually you won't need to do this, but we're going to kind of draw a line down the equal side. Because when we do the same thing to both sides of an equation, we need to know where those sides are. So the equal line is kind of the balancing point. So right now we have addition. We have positive 5 on this side, and we want to get rid of that positive 5. The way that we do that is by getting rid of adding 5 is subtracting 5. And we're going to do that to both sides. Once from the left side of my line, once from the right side of my line, or once from each side of my equation. What happens here is this 5 take away 5 is 0. So the only thing that we have on the left side now is x. That's what we wanted. That was the goal. Pretty easy to isolate the variable here. And now to simplify this, we need to just do 90 minus 5, which is 85. So that's our answer. And what I want you to do is actually check your answer. To do the check, we'll simply substitute 85 back in for x. And it's pretty easy to do actually in your head, but it's just 5 plus 85, and we want to see if that's equal to 90. And that's true. We do have 90 is equal to 90, so that is our check. If you do that on your test, you'll be guaranteed to get the question right if the check works out. And number 2, we have c minus 7. The inverse of subtracting is adding, so we need to, instead of subtract 7, add 7 to both sides. Once to the left of the right red line there, and once to the right. The same thing to both sides. Okay, if we kind of go back there and do the opposite of negative 4 and try to add 4, you'll find out that negative 7 plus 4 is negative 3. So that hasn't isolated the variable. So that's kind of what we don't want to do. We need to get rid of the things with the variable. So here we're going to add 7. And what happens is negative 7 and positive 7 cancel out. Negative 4 plus 7 is positive 3. So that's our final answer there, c equals 3. To check it, we'll do c minus 7 equals negative 4. And instead, we're going to put 3 in for c. So right here, there's a 3. And ask yourself the question, is 3 minus 7 equal to negative 4? And it is. I want you to push pause and try 3 and 4 on your own. Okay, so here's the answer. Sorry, I moved it. To number 3. We have x plus 8.75. So the opposite of adding 8.75 is subtracting 8.75. And those cancel out. What we get on the left side is x, and on the right side, negative 0.25 minus 8.75. When we combine those there, you can do it on your calculator if you need to. It's negative 8.5. To check it, we'll do negative 8.5 plus 8.75. See if it's equal to 0.25. When you do that math on your calculator there, you do get 0.25. And number 4, opposite of subtracting 9 is adding 9, so we get y equals 14. Here's the check. It's really quick to do. We just plug 14 back in and verify that 14 minus 9 is equal to 5. So we're good to go. In number 5, we see ones with fractions. Don't be afraid of them, just fractions. We know how to do all this operations. We learned this back in Unit 1 and 2. So here, the variable is on the right side over here, and we're trying to get x by itself. The opposite of adding anything is subtracting it. So we're going to subtract 5 halves from both sides. So the question we're doing is really 1 half minus 5 halves. Okay. Oops, I didn't write that right. 1 half minus 5 halves. The good news is there we have common denominators. 1 minus 5 is negative 4. So this is really equal to negative 4 halves. So the final answer when we do, oops, another mistake there. The final answer is actually negative 2. When we subtract those, we actually get x equals negative 2. And the check on your calculator you can do is 1 half equal to negative 2 plus 5 over 2. Type that in your calculator on the right side there and see if you get 1 half. And it works out. Number 6, we add 24 to both sides. And we get p is equal to negative 29. And as you can see, I didn't even draw the line down the equal sign that time. Don't forget about that check though. The check is negative 29 minus 24 equal to negative 53. And it's true. Now we have kind of pictures, and we're going to do the same thing basically. We're trying to isolate the triangle. So to get that triangle by itself, we're going to get rid of one square on both sides. So here, the square or the triangle is actually equal to 4 boxes. So that would be the solution there. Or really x equals 4 because there's 4 boxes. And then this next one we want to try to solve for x. We can still take away the same thing from each side. So 1 from each side, 1 from each side, and 1 from each side. So here we have x equals 6 on the right. Thanks for watching, guys. See you tomorrow.